Someone asked this question under my last video about binary search, which you can find in the description. I really liked the question and decided to make a video about it. There's a n by n multiplication table where n is odd. Find the middle element when the numbers in the multiplication table are sorted in increasing order. For example, in a 3 by 3 multiplication table, the numbers are 1 2 2 3 3 4 6 6 9, so the middle element or the median is 3. You might think we can just construct the multiplication table, but the constraints on n is n less than equals 10 to the 6, which makes the n squared solution impossible. Pause the video to think of a solution on your own. I will explain the solution if you tried it. Now, let's think, what do we need for a number to be the median? Simple, it has to be in the middle of the array when sorted. Meaning it has floor of n over 2 elements greater or equal to it and floor of n over 2 elements less or equal to it. You can focus on the greater elements, but I'll personally use the number of elements that are less than a number to find the median, because it's easier. Let's try to make a formal definition. For a number to be a median when n is odd, it has to be larger or equal to at least CL of n over 2 elements, since we know that it's equal to itself as well. Now, what other elements have this attribute? The numbers that are larger than or equal to the median, meaning the median is the smallest value among numbers that possess equality. If you watched my last video, you'd immediately realize this means binary search is possible. How can we find the number of elements that are smaller than or equal to the median? Quite easy. We can loop over 1 to n on each row I of the multiplication table and take x over I to get the elements that are smaller than or equal to the median. Let's shortly prove this. The entries in the row are I, 2i, 3i, 4i, up to n times I. An entry k times I is less than or equal to x if and only if k is smaller than or equal to x over I. The largest k that satisfies the equation is by definition I equals floor of x over n. Therefore, the entries that are less than or equal to x are exactly I, 2i, 3i, up to floor of x over n times I. And their count is floor of x over I. Let's solve for n equals 5. N squared equals 25. We're going to take the max of n and mid over I. Since there are n elements to be bigger or equal to than, the total must be greater or equal to 13. The smallest element that fulfills this quality is our answer. Left equals 1, right equals 25, and z equals -1. Mid equals 13. 5 plus 5 plus 4 plus 3 plus 2 equals 19. 19 greater than 13, since it fulfills the qualities. We set ans to 13, and to look for a smaller value we set r equals 12. Left equals 1, right equals 12. And z equals 13, mid equals 6, 5 plus 3 plus 2 plus 1 equals 12. 12 less than 13 since it didn't fulfill the qualities. We set left to 7 to look for larger values. Left equals 7, right equals 12. And z equals 13, mid equals 9, 5 plus 4 plus 3 plus 2 plus 1 equals 15. It worked. Right equals 8, and z equals 9.
Left equals 7, right equals 8, and z equals 9, mid equals 8, 5 plus 4 plus 2 plus 1 equals 13. It worked. Right equals 7, and z equals 8.
You can try for mid equals 7 on your own to see that it won't work. And that concludes our solution. The answer is 8. If you have more interesting questions, please post it in the comments. Thanks for watching.